Once again, we are presented with another ideal gas question with a before and after scenario. So we'll get a little bit more practice here. You've got a tank containing a low density gas and it has a pressure gauge on it that reads 100 pascals at 20 degrees Celsius. What will the approximate pressure be when the temperature goes to 50 degrees Celsius? So right off the bat, I'm just going to convert those temperatures. We already know that Celsius doesn't work for us. So I get 20 degrees Celsius, I simply add 273 to get 293 Kelvin. And by the same token, 50 degrees Celsius plus 273 is 323 K. Now once again, this is a before and after scenario using our ideal gas law. So let's write our ideal gas law down first and figure out what's constant and what changes. And it's simply PV is nRT. Well, it's a closed tank, so the number of molecules in the tank will not change. So I'm going to circle all my constants once again in green. That doesn't change. R, my gas constant, obviously doesn't change. Temperature's changing. The tank is a metal canister, so the volume is constant. That's not going to change at all from scenario A to scenario B. So my green constants are volume, number of moles, and R. Again, we'll get those to one side of the equation and put all our variables, which is our pressure and our temperature, on the other side. So what do we get? I get pressure over temperature is equal to N times R over V. Or as we did before, I can say my pressure over my temperature, that ratio is constant. So what we're going to do is the same thing. So using our same technique that we saw in the previous question, we've got our initial pressure P1 and our initial temperature T1. That ratio has to be constant. So it has to equal my final pressure, which I'm calling P2, and my final temperature, which I'm calling T2. Now if we plug in our variables, P1 is 100 pascals. T1 in Kelvin is 293 K. P2 is what we're looking for, and T2 is 323 Kelvin. And if I solve this thing for P2, I end up getting P2 is 323 Kelvin divided by 293 Kelvin, all times 100 pascals. And if we work this out, we get our pressure equaling 110 pascals. So it's increased by 10%. Notice my temperature has also increased by 10%. It's gone from 293 Kelvin to 323 Kelvin. So a 10% jump.